Just down the coast from Core Castle is this newly renovated home, originally built as a fish factory, and until recently a gutted and rotting fish factory. This remarkable transformation was achieved with extensive use of lime under the guidance of the Roundtower technical team, headed by Kevin Holbrook.
The structure had stood as a ruin for 50 to 60 years. It had had no roof, and water and the elements and vegetation had all ravaged the building. This had resulted in mortar being lost from the core of the masonry. Also, the external lime coatings, as in this, had since been lost. So at this point we had to embark on a really major job of repointing, reinserting the core fill, which is the mortar that's in the centre of a masonry wall, and localised grouting. And in this situation we tended to work with slightly weaker mortars, which were predominantly made with lime putty and a pozzolanic additive.
Right. What sort of pozzolanic additives are more typically used? What would be added to the lime?
Brick dust, traditionally, going back to the Roman period, of course, they were the great advocates of using pozzolans. So brick dust and clay products would have been the predominantly preferred choice. But today, in fact, we use a product called Metastar, which is a product from burnt gina clays, and we find them very controllable.
So on this facade that we can see here, what is the actual makeup of the lime process here?
Well, lime is produced from limestone, and in the case of hydraulic limes, it's produced from an impure limestone. That's a limestone that has impurities in the form of silica, alumina, various clays that during the process, the burning process, will produce what's known as calcium silicates, which are in fact the setting components or the hardening components for mortars.
So Kevin, there are broadly two categories of lime, hydraulic and non-hydraulic. Now, hydraulic lime was used here. Can you explain why hydraulic lime was used and not non-hydraulic lime, and what the difference is?
The principal difference between the two is that hydraulic lime actually has a chemical set. If you mix a mortar with hydraulic lime in an aggregate, it will set in a definite time period. Non-hydraulic only sets by carbonation with the air, with carbon dioxide. And for instance, if it was left in a permanently damp situation, it would never harden. Or a situation where it was devoid of contact with carbon dioxide or the air, again, would never harden. Now, as you say, we used hydraulic lime here in this situation, and the reason we did that is that by and large, hydraulic limes are a more durable material. They will stand the elements, the weather, the wind and the rain better than the softer non-hydraulic mortars, and so that's why we use this choice. Non-hydraulic lime mortars have been used and are used externally, particularly in the southeast of England, where we might have timber frame buildings, earth structures. But in this situation, where we had masonry in a marine location, we needed a more durable material.
The colouring that we can see here, this is not the natural hydraulic lime colour. Something else has been added to this. Yes,
it was commonplace that when lime mortars, lime renders and plasters were used, they were covered with a decorative coating known as lime wash. Now, we've added a yellow pigment, an ochre pigment to this to give it this nice yellow tinge. Quite often it was just pure white lime wash. And although we see this as a decorative skin, in fact it was the final element of something that's known as the lime process, which starts with our various coats of plaster and then ends with this lime coating. And it's the first sacrificial skin. It's the first skin of protection.